Wow, this train behind me is so cool. This is a superconducting maglev train, and it can reach speeds of up to 600 kilometers an hour.
There is a global race happening right now, but most people don't even see it. It's the race to build the fastest transportation on Earth. China just tested a maglev train, pushing towards 700 kilometers per hour, a speed that could redefine travel between cities. But across the Pacific, the United States is still struggling to modernize its rail network. Has the future of transportation already been decided? The moment that shocked the world. The world has seen fast trains before. Japan's bullet trains and Europe's sleek rails already move faster than cars. But nothing has prepared people for what happened in China. A train just hit 700 kilometers per hour in seconds. That is almost 200 meters per second, faster than many small airplanes take off. Engineers, journalists, and transportation experts were stunned. Videos of the test went viral online. People kept asking the same question: how is this even possible? This train is not a concept. It is real. The speed it reached is far beyond almost any existing train. It could cut trips across large cities or provinces to just minutes. The test showed that humans can travel on the ground almost as fast as flying in the air. Governments, companies, and engineers around the world started paying attention. Many admit they did not expect such technology to be ready so soon. Some experts even called it a new era of transportation. The impact is bigger than just speed. This breakthrough shows how quickly technology can leap forward when a country focuses on research and development. While some nations are still building traditional high-speed trains, China is testing a train that almost feels like science fiction. The train glides silently above the track, using magnets instead of wheels, avoiding almost all friction. Every second counts when it comes to acceleration, and this train made every second matter. The moment was not just a test, it was a warning. The world is now seeing a clear picture. The future of transportation is changing faster than expected. Countries that fail to keep up may be left behind. China has set a new bar that others must reach if they want to compete. How can a train move this fast without even touching the ground? The secret is a technology that feels like magic, but is very real. A train that doesn't touch the ground. Most people think of trains as heavy machines rolling on steel tracks. Wheels, rails, engines, and brakes. But China's newest train is completely different. It does not touch the track. Instead, it floats above the ground using magnets. This technology is called maglev, short for magnetic levitation. Magnets push and pull the train in a way that lifts it slightly above the rails. Because it floats, there is almost no friction slowing it down. Friction is what makes cars and normal trains slower. By removing friction, this train can reach extreme speeds that older systems can never match. The track itself is special too. It is not just steel rails. Powerful magnets are built into the track, and the train reacts to them perfectly. It floats and moves smoothly, almost silently. Passengers inside feel almost no vibration. At very high speeds, even a small bump on a normal rail can cause big problems. But with magnetic levitation, the ride stays steady, even when moving at 700 kilometers per hour. Engineers can now think about creating trains that are faster than almost anything people have seen before. Acceleration is another secret. Unlike normal trains, this maglev train can reach its top speed in just seconds. Regular trains slowly gain speed over kilometers, but this one jumps to ultra-fast velocity almost instantly. That is why the world is shocked. It is like watching a rocket glide along the ground. Experts say this technology is safer, faster, and more efficient than almost all traditional high-speed trains. Maglev trains are not just faster, they also use energy smarter. With less friction, the engine does not need to work as hard, which means less energy is wasted. This could make long-distance travel cheaper in the future. Countries looking at this technology are realizing that old railways may soon feel like ancient history. The real question now is how China managed to get so far ahead while other countries struggle to build trains that even move half as fast. The race for the fastest train on Earth. For decades, countries around the world have been trying to build faster trains. Japan created the first bullet trains, racing across the land at incredible speeds. Europe followed with sleek rails connecting cities in record time. Germany experimented with magnetic trains. Everyone wanted to be first, and everyone wanted to show that their country had the fastest rail system on the planet. But even with all this competition, nobody expected what China would do. China has been quietly building one of the largest rail networks in history. Thousands of kilometers of high-speed rail, now connect its biggest cities. But building long tracks was only the beginning. Engineers wanted more. They wanted speed. They wanted to go faster than any train ever built. And now, after years of testing and investment, China is reaching speeds that others can only imagine. Part of the race is technology. Maglev trains, the ones that float on magnets, have always been faster than traditional wheels-on-rails trains. But they are expensive, and very few countries invested enough to make them real. China, however, spent billions, trained thousands of engineers, and focused on making this dream a reality. The results are shocking. The train can accelerate to 700 kilometers per hour in seconds, faster than most commercial airplanes when taking off. The race is not just about speed, it is about national pride and power. Countries that lead in transportation technology gain respect and influence. They can move people and goods faster than anyone else. This means more business, more efficiency, and more control over the future. China understands this better than most. While other countries were debating costs or politics, China built the infrastructure, perfected the technology, and tested it at record speeds. The world is watching now. Experts ask, will other countries try to catch up, or are they already too far behind? High-speed rail is no longer a luxury. It is a statement, and China's new maglev system is the loudest statement yet. But how exactly did China achieve this breakthrough so quickly? And what strategies allowed it to leap ahead while others struggled? The answers are both surprising and revealing. China's 700 km per hour breakthrough. China's new maglev train is not just fast, it is revolutionary. Engineers have designed a system that uses powerful magnets to lift the train slightly above the track, removing almost all friction. Without friction, the train can accelerate incredibly quickly. In just a few seconds, it reaches 700 kilometers per hour. For comparison, most high-speed trains in Europe or Japan only reach about 300 kilometers per hour. The difference is massive. The test tracks are specially built to handle this speed. They are long, straight, and reinforced with technology that ensures stability. Every curve, every beam, and every section of track is calculated to perfection. At 700 kilometers per hour, even the smallest mistake could be dangerous. That is why engineers spent years perfecting the track, the train, and the control systems. Safety is as important as speed. China's breakthrough is not only about engineering, it is also about planning and investment. The government committed billions of dollars to make high-speed rail a priority. Thousands of engineers and scientists worked together to develop the maglev system. Research centers and testing facilities were built to experiment with new materials, magnets, and aerodynamics. This kind of focus and coordination is rare. Many countries want innovation, but few invest enough to reach this level. The potential impact is enormous. Cities that once took hours to reach could now be connected in minutes. Business, travel, and trade could expand rapidly. For millions of people, commuting and traveling could become faster, safer, and more efficient. Some experts warn that challenges remain. The system is expensive, and building maglev tracks is not easy. But the proof is clear. China has already reached speeds that make most trains in the world look ancient. The real question now is why the United States, a country with huge resources, still struggles to build modern high-speed rail, and what this speed gap means for its future. Why China is moving so fast. China's rise in high-speed rail is not an accident. It is the result of planning, focus, and massive investment. While many countries debated politics, costs, or regulations, China committed to building the fastest trains in the world. For decades, the government invested billions of dollars into rail infrastructure, research, and engineering schools. Cities, provinces, and industries were all connected through one giant vision: to make transportation faster, safer, and more advanced than anywhere else. One reason China moves so fast is its long-term planning. Unlike countries that stop and start projects, China works in decades-long plans. Engineers and scientists are given the time, money, and resources to experiment. Testing and development are not rushed. Each failure is a lesson, and each success is expanded. Maglev trains, the ones that float above the tracks using magnets, were being studied years before the world realized their potential. By the time other countries considered them, China was already building prototypes. Another reason is the scale of China's work. Thousands of kilometers of high-speed rail already exist, connecting hundreds of cities. This network gave engineers a real-world laboratory to test new ideas. They could experiment with speed, acceleration, and safety without stopping everyday travel. This experience is hard to replicate. Countries with smaller rail systems or scattered cities cannot test trains at the same scale. China also invested heavily in talent and technology. Thousands of engineers, scientists, and technicians focus only on transportation. Universities train students in high-speed rail design. Research centers test magnets, aerodynamics, and energy systems. Every detail, from track curves to train shape, is calculated for maximum speed. Ordinary countries might spend millions on research, but China spends billions, ensuring results that others can only imagine. Finally, government support is unmatched. Decisions are made quickly. Budgets are approved without long delays. Projects are coordinated across provinces. This efficiency allows China to build, test, and launch faster than any other nation. The combination of planning, scale, talent, and funding has created something extraordinary. China is not only leading in speed, but also setting standards for the future of rail travel. Its trains are a statement. Innovation without limits is possible when vision and resources align. But while China races ahead, the United States struggles to build trains that even move half as fast. Why is the US so far behind? And what challenges hold back its high-speed rail projects? America's high-speed rail problem. The United States is known for many things: technology, cars, airplanes, and huge cities. But when it comes to high-speed trains, the country is falling behind. While China tests maglev trains that reach 700 kilometers per hour, most American trains move slower than cars on the highway. The difference is not small, it is massive. One reason is funding problems. High-speed rail requires billions of dollars to build. Tracks, stations, engines, and safety systems are expensive. In the USA, politicians argue about who should pay. Budgets are delayed, and many projects are canceled before construction even begins. Meanwhile, China invests billions quickly and continuously, keeping projects moving. Another problem is political disagreements. Different states and agencies argue about routes, land use, and priorities. Rail projects often cross multiple states, creating conflicts. Some leaders want trains in one city, while others oppose them. These delays slow progress for years, sometimes decades. China avoids this by having a centralized system where decisions are made quickly. America also faces geographic challenges. Some areas are less dense, meaning fewer people would use the train. In China, cities are densely packed, making high-speed rail very efficient. Longer distances between American cities make it harder to justify the cost. But even in places like California or the Northeast, where population density is high, projects are still slow due to politics and bureaucracy. Technology is another factor. The US has engineers capable of building fast trains, but without continuous government support, it is hard to design and test systems at the scale needed. China tests trains on thousands of kilometers of track, while the US has very few dedicated high-speed lines. The result is a growing speed gap. While Chinese passengers can travel hundreds of kilometers in minutes, Americans are stuck on trains that feel ancient compared to what is possible. Experts warn that the gap is not just about convenience, it is about economic growth, efficiency, and national competitiveness. Countries that lead in transportation gain an advantage in trade, business, and influence. Despite these challenges, there are signs of progress. Projects like the California High-Speed Rail exist, but even these are slow and expensive compared to China's maglev. The question is whether the US can catch up before the gap becomes impossible to close. The difference in speed is staggering. With China moving faster than almost anything on the ground, how big is the gap? And what does it mean for America's future in transportation? The speed gap gets embarrassing. The speed difference between China's trains and America's is shocking. In China, maglev trains reach 700 kilometers per hour, moving faster than many airplanes during takeoff. Meanwhile, most American trains travel around 150 to 300 kilometers per hour. That is barely half the speed of some older European bullet trains, and almost nothing compared to China's newest machines. The gap is no longer small, it is huge. The embarrassment is not just about numbers, it is about efficiency and progress. Imagine traveling from New York to Washington, a journey that could take 2 hours on a super fast train. In the US, it can take 4 to 6 hours on Amtrak, a traditional rail line. In China, the same distance could be covered in less than an hour with maglev trains. For everyday travelers, this means wasting time, energy, and money. The gap is also a symbol of technology leadership. High-speed rail is not just transportation, it is a statement about innovation and national power. Countries that lead in rail can move goods faster, connect cities, and make life easier for millions. When China reaches speeds almost unimaginable, and America remains slow, it becomes clear who is setting the pace for the future. Part of the reason for this gap is cost. China has built thousands of kilometers of high-speed track in just decades. America struggles to fund even a few hundred kilometers of new rail. Politics, bureaucracy, and debates over land use make progress slow. Engineers could build faster trains, but without support, projects remain unfinished. The gap affects the economy too. Faster travel allows business deals, trade, and tourism to grow. Countries with modern rail networks can transport people and goods quickly, boosting growth. America risks falling behind in all of these areas if it does not catch up. The difference is staggering, but speed is only one part of the story. What could traveling at 700 kilometers per hour actually change for cities, people, and the future of transportation? What's 700 kilometers per hour? Travel could change. Traveling at 700 kilometers per hour is not just fast, it can change everything. Journeys that once took hours could now take minutes. Cities that felt far apart could suddenly feel close. A business trip that would normally take half a day could be done in the morning, leaving the afternoon free. This is the kind of change that transforms how people live, work, and think about distance. High-speed trains like this could reduce pressure on airplanes and highways. Fewer cars on the road mean less traffic, fewer accidents, and lower pollution. Flights between nearby cities might become unnecessary. People could live in one city and work in another hundreds of kilometers away, opening new opportunities for jobs and housing. Commerce could grow faster too. Products could move from factories to markets in record time. Cities could become connected hubs of trade and services. Faster transportation could even affect tourism. People could visit more places in a single day without the fatigue of long travel. The social impact could also be huge. Families could visit each other more often, students could travel between schools and cities quickly. Doctors could reach hospitals far away in emergencies. Governments and companies could respond faster to crises, using high-speed travel to move people and resources efficiently. However, these changes require investment. Tracks must be built, systems maintained, and safety ensured. The technology is expensive, but the benefits could be enormous. Countries that master ultra-fast trains could change the way people live forever. China is showing the world what is possible. Its maglev trains are not just a novel, they are a vision of the future. Other nations are now forced to ask themselves if they can keep up, or if they will watch from behind as travel speeds leap ahead. Even with all these possibilities, challenges remain. What problems could slow down this incredible technology? And how close is it to being ready for everyday people? The hidden challenges. Even though China's trains can reach 700 kilometers per hour, the technology is not without challenges. Building and running maglev trains is extremely difficult. The tracks must be perfectly straight and smooth, because even a small bump at this speed could be dangerous. Engineers must carefully calculate every curve, every section of rail, and every magnet's strength. The construction requires precision, skill, and constant maintenance. Any mistake could slow down the train or cause accidents. Another challenge is cost. Maglev trains are very expensive to build. The trains themselves, the special tracks, the stations, and the control systems all cost billions of dollars. Not every country can afford to invest at this level. Even in China, the projects require careful planning and a long-term commitment. Countries with smaller budgets may find it impossible to compete. Energy use is also a concern. While maglev trains are efficient compared to traditional high-speed rail, accelerating to 700 kilometers per hour requires a huge amount of electricity. Engineers must find ways to supply this power safely and reliably, and they must keep the systems running day and night. If the energy fails, the train cannot operate. Safety is another key challenge. Traveling at these speeds means that even small problems could become major emergencies. Engineers must design advanced braking systems, emergency protocols, and precise monitoring to prevent accidents. Passengers must feel secure, and the system must handle thousands of trips safely every year. Despite these obstacles, China continues to push forward. The government and engineers are learning from every test. Each challenge teaches them how to improve the technology. The world is watching closely to see if these trains will move from experimental tracks to regular travel for millions of people. The hidden challenges are real, but they are not stopping progress. Many experts believe that overcoming these obstacles is part of the reason China is now ahead of other countries. Innovation does not come easy, and breakthroughs often require risk, money, and patience. But even with these challenges, the future of transportation is being rewritten. The real question now is what the global rail race will look like, and whether other countries, like the United States, can catch up before it is too late. The future of the global rail race. The maglev trains in China are more than a technological marvel. They are a message to the world. Traveling at 700 kilometers per hour, these trains show what is possible when a country commits fully to innovation. Cities, economies, and people's lives could be transformed by this technology. The global race for high-speed rail is no longer theoretical. It is happening now, and China is in the lead. Other countries are watching carefully. Japan, Germany, and the United States all have experience with high-speed rail, but none have matched China's newest system. Some nations are now increasing investment in research, trying to catch up. Others are exploring new types of trains or alternative technology. The world is realizing that transportation is no longer just a convenience. It is a measure of power and influence. The speed gap matters economically and politically. Faster trains mean faster trade, quicker travel, and more efficient cities. Countries that lag behind risk losing business, investment, and global influence. For people, it means longer trips, slower access to opportunities, and less connection between cities. Nations that master high-speed rail first will have a clear advantage. Yet the race is not only about speed, it is about safety, reliability, and accessibility. Building a maglev train is useless if it cannot carry thousands of passengers safely every day. Countries must balance speed with practical considerations. China is proving that it can do both, but it will take years to make these trains part of regular life for millions of people. The future also depends on decisions in politics, investment, and planning. Countries with the resources and vision can join the race. Those without may be left behind, watching as the new era of ultra-fast rail reshapes the world. In the end, China's breakthrough is a wake-up call. It shows how fast technology can leap forward and how nations that act decisively can lead the way. The maglev trains are not just vehicles, they are symbols of progress, innovation, and ambition. The question now is not just who will be fastest, but who will shape the future of travel, and how ordinary people will experience the world as distances shrink and speed becomes the new standard.